All right, so for Unit 11, we're going to be both graphing some of our trigonometric functions and solving equations involving our trigonometric functions. So as we're graphing, though, we're really only going to graph two trig functions this year, the sine and the cosine function. Okay, so we'll leave the tangent and all the reciprocal functions for you in later classes. But both of these functions, as any other trig function, are what we call periodic functions. That means that they're going to repeat or start over after what we call at regular intervals, which we are going to call cycles. Okay, so all of the trigonometric functions are periodic. You can kind of notice right here, can you see they're also called sound wave or sine waves or cosine waves right here, because they look like waves. They're just going to kind of go up to the top, down to the bottom, and just kind of keep repeating. They're periodic. So the period is the length of a cycle. So right here, the period, they're measuring it from the tallest point of this nice, lovely sine curve right here. And it goes all the way down to the bottom before it returns up to the top. So the period is just that distance between the maximums right there. So what is that distance measured along your x values right here? So since they didn't mark it, we don't know what that is, but it's just that length or that the x length right there between the top of one of your periodic cycles to the top of the other one. Okay, now the amplitude, let's change colors here. The amplitude is going to be a y value. It's half the distance between the maximum and the minimum values. So basically, if you were to take this, notice actually, let's come over here because this is where they did it. They just took halfway in between. So since it's 4 to the midline right here, our midline's always going to be 0. In this class, it's not always 0, but ours is going to. So you could just count that distance right there is 4. But that's what we call the amplitude. Okay, so the period and the amplitude are going to be huge key when we're graphing and when we're writing equations. So let's show you how this works. So we're going to graph both of these curves right here. We're going to start off with the sine curve. We'll make it right here. Whoops. We're trying to make it so we could see both the sine and the cosine. What's wrong with me? Okay, so right here, as we're graphing right here, what we're doing, basically, we could start off with an XY table or a theta Y table, I guess is what we could say. So instead of our X's, we'll put in our angle values right here, and it will give me a Y value right here. So remember that the sine really is the Y value. Down here, the cosine is the X value. But so when we put in any of these angles, so say we want to start, let's do this in red so we can see this really show up. So say we want to start at 0. That's our X interval 0. When we're looking for the sine of 0, that's our Y value. So the sine of 0 is also 0. So 0, 0 is a point on our graph. Okay, as you'll notice right here, the next theta that they've got ready to graph is pi halves. Okay, so when we look at pi halves, here's our pi halves on our unit circle. When we look at that y value is 1. So at pi halves, we're going to plot 1. That's our x and our y value right here. Okay, at pi is the next one. Here's pi over here. Our y value is 0. So we're back to 0 right here. At this 3 pi over 2, notice that's our next one right here. 3 pi over 2, my y value is -1. And then at 2 pi, I'm back where I started at 0. And that is 1 full period. It will start over again and do another thing. Now, it does the same thing over here. These are just negative angles now. But remember, if you want negative pi halves, instead of going negative or positive 90 or positive pi halves, to go negative, you just go the opposite direction or clockwise right there. So this is our negative pi halves. It's really 3 pi halves. But our y value here is -1. So you can mark that right there. Negative pi and positive pi are the same. Your y value over here is 0. negative 3/2 pi, that would be when we started here and went all the way around to our 90 degrees. So that is 1 right there. And then negative 2 pi is all the way around. And so we're back to that 0. So if we were to kind of connect these dots right here, we would have a nice, lovely picture that looks like waves. Maybe you're better than I am at drawing these, but it'll go back up. Okay, so that's what our sine curve looks like. Now, again, we talked earlier, there's 2 important things when we're graphing or writing equations that we notice. First of all is the amplitude. So remember, the amplitude is just from our midline to the lowest, or our midline to the highest. So how far is it from the midline, which is 0, to the top, which is 1? Well, our amplitude is just 1. Okay, midline to the bottom, -1, that distance is also 1. And then the period, remember the period is when I always just start, I look at it at 0. See how it's in the middle right here? So a period is when it goes all the way up to the top, back to 0, but then also all the way down before it goes back to 0. So that would be considered 1 period. So from the x between those 2 points, and I just covered it up, but this is 2 pi right there. So, and that makes sense with the unit circle. The unit circle goes to 2 pi and then it just starts all over. So the period of that is 2 pi. All right, let's look at the cosine curve. It's actually not too much different. Let's try a bright blue on this one. Okay, so this time when we're graphing our theta and our y, this time remember we're looking for the cosine of theta, and our cosine is our x values. So when we look at these, if we start at 0 right here, here's my 0 radians, but my x value here is 1. So for the cosine curve, when y is 0, our x is, when our x is 0, our y is 1 right there. Okay, then pi halves is our next one. I won't write all these out, but let's try pi halves. Here's my pi halves. Our x here is 0. And then pi, over here at pi, my x is -1. 3 pi halves, my x is 0. And 2 pi, we're back, starting over again. So there's 1 period right there. It goes from our 0 clear up to, whoops, I skipped a point. That should be on that 2 pi right there. Let's see if I can figure out how to erase this. Got it. All right, so we can do the same thing if we go backwards to negative pi halves. That's this one, so it's 0 right there. Whoops. I didn't quite change my color back. Okay, so 0 right here. What is going on? Okay, I want blue. And there's my 0. And then at negative pi, I'm here at -1, 0, and 1 is my -2 pi. Okay, so the sine curve looks very similar to our cosine curve looks very similar to our sine curve. The only difference between these two, like you could pretty much pick one up and put it on top of each other, but it just shifted over a little bit. So the main thing I want you to remember and realize is that a sine curve, we're not doing any phase shifts this year, so we're not going to move these. So a sine curve is always 0, 0. At 0, your y is 0. Okay, your cosine curve will always be whatever the amplitude is. Okay, so whatever that amplitude, the cosine will start at that amplitude. On this one, my amplitude is still 1. It's just 1 above my midline. And the period, that means I'm looking from this point right here where I'm at the top of the cosine curve all the way till I get to the top again. Again, this period is 2 pi. All right. Oops. That's it for this video. We'll go on in our next video.